Well, hello and welcome back. We are continuing season 28. We're finding the cracks. This time we're not looking for cracks. We're scraping the rust off, basically, and we are continuing part two of a great conversation where we're like switching gears a little bit and digging into the deeper side and looking at rust and the idea of a solid, well-founded language, well-structured language, and how it can help us in the world of AI to maybe write better software so we know our software is good before we dig into the cracks that AI exposes. But before we get back into all that, introductions are in order. This is Developreneur Podcast, Building Better Developers. I am Rob Broadhead, one of the founders of Developreneur, also the founder of RB Consulting, where we help you avoid expensive mistakes in your technology before you make them. It's usually the best time to avoid those suckers. Good thing and bad thing. Good thing is... the bad thing is I have a struggle right now thinking up a good thing because sometimes we rack up too many of these and I forget where I'm at, what I'm doing, what are the good things, what are the bad things, what have I shared, what have I not. The good thing is it doesn't really matter that much because the bad things aren't that bad. The good things are we're here. This is a really fun conversation. And this is the ongoing thing. And I will share a little bit, and then I'm going to toss it to Michael. It's like, we've even talked about, like, what happens if Developreneur goes away? What is it? What if it changes, stuff like that? And both of us are like, well, we can't do that. We love doing this that much. We love you guys. Look, little affirmation. The world needs a little bit more. And it's not even just like, everybody shares a Coke and a smile. It's like you share a Developreneur and a smile. Michael, share your smile and your background as well.
Hey everyone, my name is Michael Malash. I'm one of the co-founders of Developreneur, Building Better Developers. I'm also the founder of Envision QA, where we help you fix broken systems and replace the guesswork with tested, dependable solutions built around your business. Good thing, bad thing. Kind of this conversation, we love Developreneur. We don't want to quit it, but the conversation we're having, this is part two. I have to say, the good thing was it was so much fun to geek out. The bad thing was now it's giving me so many freaking ideas to go play with my Raspberry Pis again with Rust, and I don't have time. It's like, oh, come on. But I have a feeling I'm going to be dusting the Rust off my Raspberry Pis and digging them out and starting to learn a little bit more about Rust.
Yeah, dust a little rust off so you can put a little more rust on. Rust on, rust off. Okay, enough of that. Let's dive back into the conversation. And this is a good one. Take some notes. We will have links for all of this as well that are in the show notes. You guys can check them out. But this is something we haven't done in a while. So I think this is a great couple of episodes. And we're going to dive back into it. Here we go. Yeah. Well, that sort of leads to one of the challenges with languages in general. And I know C++, well, back in the day when I learned it, it wasn't that bad, but it did grow to this. React lives in this world. Python lives in this world. Is the libraries, is what the core language gives you versus all of the different extensions and libraries that are on there. What is it like in the Rust world as far as, the standard, like the Python thing is like, oh, I've got to include this, or I got to include that. I've got to include the other thing. I know C++ got to that, which libraries are there. How does Rust handle libraries and that sort of extensive extension of functionality?
Yeah, that's a great question. I've heard some people critique Rust standard library compared to something like Go or Python, definitely in that. It takes a while, and each language community has their own kind of philosophy around that. I don't know officially what Rust, like the Rust Foundation's stance on it is, like how much they bring into the standard library versus not. But it's a pretty useful and pretty comprehensive standard library. And it's very well curated, too. I find the patterns to be mature and consistent throughout it. You can learn a lot of good practices by looking at some of the source code in there. I mean, some of it, if you're a newbie, you look at it and you're like, what is this? But a lot of it, though, is very understandable and very well documented. So it's a very mature set. Now that being said, Rust is still relatively young and new. So it's a work in progress, but I see a lot of progress there. And there is both like a standard library set that can that targets like bigger machines, and then there's also like an embedded set. So for those more limited device resource types of devices, they would call it heapless type things, where you're just doing everything on the stack for memory management, and that is a long ways still to catch up to C and C++, but it's rapid. It's starting to pick up its pace on that as people use it more and start, feeling a little bit more comfortable moving away from C or something there.
Is that sort of how you found it as well, Bob?
So I come to Rust and I find as a newbie the standard library pretty minimal, but that's a good thing as well. But I was surprised, for example, that regex, for example, was not part of it. And then you come from Python, and the standard library is humongous, right? Which probably also has a cost. But I always have really enjoyed the standard library in Python. You have almost everything. It has, as Jim says, same with Python. You have good coding standards, and you can learn a lot by just looking at the code and coming well versed in it. Like modules like func tools and iter tools. It's beautiful. But then later in Rust, you actually learn that all these things are there as well. It's just a little bit different. Like maybe when you call a built-in as a function, then in Rust you would do it like a dot method, but you have the same kind of iterator protocol. And I was actually surprised how much Rust has, while the standard library seems smaller, right? So, so far really good.
Yeah,
and then you have the common packages you usually pull in, like Pedantic, and that's a very important package for validation. But that will be in a PyPI package, right? That's stuff you just add to your project TOML, and that will be external.
Yeah. I find too that a lot of what's not in the standard library is pretty well made up for in the third-party crate space. So like Rust refers to its library packages, and that is crates. And there's a website, crates.io, where you can go, and it's pretty much the like NPM repository of everything that you can pull into your application, and it's pretty extensive. There's quite a few things. So as I said, I don't know the official community stance on what goes into the foundation of the standard library versus what stays third party, but it's working. There's a lot of good third party stuff that you can trust if it's not in the standard library, and it's I haven't found something where I'm like, I really wish that existed. That's a real deal breaker. Also because, like, with AI, if something truly doesn't exist and it's small enough and it's standing in your way, you could just have Claude make it for you.
What is, especially now that it's been around a few years, you guys actually have slightly different backgrounds. Are there certain languages that people may have used before Rust that are going to help them adopt Rust faster versus some that are like, this is very different? I would think of like as an example, just throw something out there, is like C and JavaScript are going to be very different. So if you're trying to learn JavaScript from C, you're probably going to there's a lot of things you have to think of, and vice versa. Are there some that are very, what are some of the languages that are, I was going to say, sisters or brothers to Rust? And then maybe what are some others that are very different, and you're going to have to expect a bigger ramp up coming to it?
I think, Jim, you have more experience there because didn't you learn some Haskell and Elixir and stuff, and that could be maybe more related to Rust. Where me as
Not
Python, I definitely am a stranger from the get-go.
Yep. Definitely C++. So if people don't know, like Rust comes from Mozilla originally. There was a developer in the sort of mid-2000s who was, I don't remember his impetus for it, but he created this as a pet project, and it first got applied in Firefox, if I'm not mistaken, was the first use of Rust. And He definitely was looking for a C++ replacement, right? So Firefox was a lot of C++ originally. I still think there's quite a bit in there. And yeah, like C++, you can definitely see the relationship there, but not entirely, right? So I had 25 years of C++ coming to Rust, and I still found my eyes not able to fully read it and understand it. There's enough that's different. And that's where like something like Elixir, so a real functional style, you could say the implements Rust parlance, the combinator pattern, where you're chaining things together with dots, right? So something like an object dot something dot something dot something, and familiarity with that will give you a heads up on Rust. So any language that exposes you to that, and C++ does a little bit, but it's like not consistently applied still to this day. It's not the style. That definitely helps. And if I'm remembering correctly, Haskell was also a somewhat inspiration for Rust as well. So they've taken some things from Haskell. I'm not familiar with, I've never done Haskell, but I think some of the design patterns were emulated from Haskell and brought over to Rust. So I think if you're good at Haskell, you'd find yourself at home in Rust. But yeah, if you like all you knew was Go, for example, Rust is going to feel a lot more expansive and complicated. Although, Go is starting to incorporate some similarities there. So I don't know, maybe not.
What about the borrow checker and ownership model? Was that totally new in Rust, or did that also come from somewhere?
I don't know its exact origin. It's obviously it's an innovation on top of the C and C++ memory management model, right? And it's just making it even more strict and helpful for you ultimately. So, immutability by default, which creates the need for borrowing a lot, right? So getting a reference to another piece of memory sort of comes out of that. So any language where you're having to somewhat manage your memory and use references and be aware of if you're copying or moving or borrowing, essentially, you'll feel pretty at home at Rust, right? So then it's just sort of learning the specifics, the lingo, the keywords, the block structure differences, that kind of thing.
Yeah. No, I asked because that's one of the big pieces that somebody has to learn when they get to Rust. They always hear like they're fighting the borrow checker, right? And then it finally makes sense, and it's very pleasant actually. But
indeed,
so yeah,
that becomes your friend.
Part. Yeah, but that gives us the guarantees, right? The typical pointer issues that are then resolved in Rust.
That is the reason. So the first time I wrote a piece of embedded software with Rust, and I put it on a Raspberry Pi Pico, where you don't get that built-in memory protection by default, either from the chip or the operating system. And I didn't get, the typical Heisenbugs of like I'm doing something wrong with my memory management in my C program. It ran right away without any of that, and I've never seen a single one of those bugs in Rust, which is remarkable. I've spent countless hours trying to find those bugs in my early embedded code.
God, that takes me way back, back to my early DOS days, having to deal with high, low memory, C, and pointers, and oh my God. So I want to take this a little bit further because in Vision QA, I deal a lot with QA and test pipelines and things like that. In Rust, how is the test framework structured? Is it good for unit testing? Does it have its own built-in continuous integration for like regression testing, integration testing, or do you have to rely heavily on third-party tools to work with Rust?
It's all built in, right?
Yep.
So what I'm seeing, what we present in the cohort is you have a unit test in the module, and as far as I know, you don't have to import any crate for that. So it's very easy to write tests and just sit right under your code. But I don't know, Jib, you have more knowledge on the different types of testing and the integration and stuff. So.
Yeah. Yeah, there's built-in attributes, right? So Rust has a concept of an attribute that defines a test harness, and it's by convention. You don't have to, but unit tests typically go in the same source file as what you're testing. Although I've found working with AI, there's actually a strategy to separating it as well, where you could freeze tests. You could freeze those files so that AI can't go back and like bias the test, like write the test to what it's writing currently, right? And sort of shape that test towards it and soften it up. So I've actually shifted a little bit in my approach even recently there, but yeah, everything that you need is pretty much built in. Now, the only thing that Rust is a little bit harder to do, not impossible, but that's like introspection on objects, if you will, and being able to like look at the structure and the type of everything as you're going along. You don't always need to do that, so it's a little bit of a paradigm shift. So if you're used to that, you'll struggle a little bit because your instincts are gonna be to wanting to do that as you go along, especially if you're doing something like serializing JSON on the wire or something like that. You just have to work into Rust's constructs that it gives you out of the library, and use Rust's strong typing and structures to basically take data, have your test essentially put it into an object structure, and if it serializes okay, then you're fine. You don't need to go any further than that and do the more dynamic language introspection kind of thing, right? Where you're at these like more generic type levels of tests. Right?
Jim always laughs at me. Like, there's a whole suite of tests you don't have to write in Rust.
No, exactly.
You guys have to do that in Python.
And Claude wrote those tests originally, the earlier version 4. It would literally write these tests that would test the structure of like a struct, but it would just put in some like pseudocode comments. It wouldn't actually implement something because it sort of had the instinct that they're not needed. But then it would also write those literally, and I'd look at those tests and I'd be like, are these really needed? It's like, oh, of course, you're right, they're not. They're useless. So testing is first class. It is first class, and it is built in Rust, and I find it pretty much everything that I need. It's just a little bit of a paradigm shift coming from a dynamic language.
Yeah. Now, still on the testing side of things, though, what about profilers where you're looking or able to monitor the memory and that memory usage? Since this is a compiler based, I'm sure there's different profilers and tools out there. How are they? Are they pretty solid, or do you still have to rely on like writing some custom pieces to make it work the way you want?
I haven't gone super deep in that yet with Rust, but I know some people recently who I followed a guy who's writing a piece around this called Hot Path. I'm blanking on the other one that somebody I know was using recently, but it's pretty well developed there. You can get, it's at least to the level of C++. It's my understanding of it. So anything you can do there, you can definitely get the zero in on the hot paths. You can see definitely across your stack what's being called, how often. You can zoom in on memory usage. I'm pretty sure you can go as deep as you want there. But like I said, I haven't personally dug deep in there yet. I haven't had a need to yet.
What about you, Bob? Any experiences with any profilers? Or...
Not in Rust. But yeah, Python C profile, the built-in. But yeah, not recently. But that worked pretty well. Even in the video on YouTube. It's a nice tool. Yeah.
Before I hand this back over to Rob for a second, what are some advantages that you see from other languages and Rust around testing? Because I know you pointed out the one, you don't have to write the pseudo JSON scripts anymore, things of that nature. But what are some other advantages or even disadvantages that Rust might have that other languages might have in their test suites?
I I don't know if I would say that Rust has an advantage. I think it's on par with other languages. Maybe the one advantage is, at least compared to like C++, it's all built in. That's actually a consistent theme compared to C and C++. Those languages just came out as languages for the longest time and sort of stayed separate from their tooling and configuration around it. Whereas Rust and Cargo go hand in hand. Right? They're inseparable. And same with testing. The framework's built in. It's not third party. It gives you just the right amount of what typically you're looking for and nothing more. And that's what I appreciate about Rust. So it's sort of, like I think in C++, I understood like a lot of the nuances of the environment because I had to go out and select different things for testing, for build tools, etc. Rust, it's all provided. It works really, really well. And so like I actually find myself not having to understand those things in gory detail anymore, which is nice.
Yeah, I like that test is integrated in Cargo. I think UV might be working on that as well. But yeah, with Python, we pull in PyTest, and it's an amazing framework. And we have the extra step of the type checking that you really need to do. But the compiler already takes care of that in Rust. So that's really nice.
So along those lines, what is the, I guess we'll step back out a little bit out of the details of it a little bit more, but like, what if somebody's starting into Rust, what is the expectation of IDE support? And I don't even know if it makes as much sense when you're talking about a compiled language, but static code analysis tools that you see that are sort of the standards elsewhere.
IDE-wise, I'm a bad example. I use Vim. Rust Rover. Do you use Rust? What do you use, Jim? Because I think
I just switched to Zed recently in the last couple of weeks from VS Code. But yeah, it was a long. My fingers still want VI key binding, so I bring those along. But I was a long time VI user, and then VS Code, and now Zed. Yeah, and they're all first class support on Rust.
Yeah.
Excellent. Well, we are sort of running out of time, so we will have some bonus discussions a little bit about Rust as well here. But I want to thank you guys for your time, for your evangelizing, and allowing us to pick your brains a little bit as far as your experience with it, because it is. As you guys know, probably there's so many languages out there. There's so many tools and ways to go, and it's always nice, especially we've said in this world of AI, to have something that helps/forces you to do things right a little bit. And so it's just that much. I think it's going to be one of those things. It's just that much better as we move forward to have languages that, when you look at it, it actually makes sense and it has some of those enforcing mechanisms, as opposed to like. And I don't want to pick on Python too much because I love it, but also I have a love-hate relationship with it this time, because it allows you to have some very interesting things put together, much like obfuscated C and some of those other things that you can. There's a lot of power in it, but there's a lot of ways that you can write stuff that is essentially not human readable, or some level of that. So appreciate your time. Appreciate everybody that has been hanging out with us. I guess if somebody has more questions or would like to reach out to you guys and learn a little bit more about Rust, what's the best ways to get a hold of you? And I guess we'll start with you, Bob.
So I have my own site, belderbos.dev. That's my central hub. Pretty active on the blog there. I have my coaching, and together with Jim, we run a scripter2rust.com, which is our 6-week program for any, mainly targeting Pythonistas, but any scripter, PHP, Ruby is welcome. And we guide you, we take you on a journey to get those basics down in Rust, and you're actually writing a performant JSON parser from scratch, and it's a really exciting program.
And Jim?
Yeah, I have a coaching business as well, and you can find me at refactorcoach.com. It's all one word. And Bob already gave the link to the cohort. That is one of the best ways. You can find both of us too on LinkedIn. We're both pretty active there. Yeah, I think that's my main places.
Excellent. Well, thank you so much for hanging out with us. Those of you guys that have been hanging out with us as well, appreciate your time and working on becoming very specifically better developers, I think, this time around, as we've gotten a little bit deeper and a little more into the weeds, as it were, of a language. But I think it's always good. It's been a while since we've done this. It's fun for us to come back down and talk on like specific languages and implementations, as opposed to just theory and things like that. So those of you listening, thank you so much. Have yourself a great day, a great week, and we will talk to you next time. And so now for our bonus, I was thinking about this. I think what I'd love to hear from you guys is like your recommendations for somebody that wants to get started in Rust. What would be the best way to get started? And I'll let you guys flip a coin, whoever wants to dive in first.
Do you want me to take that one first, Jim?
Let's see.
I can go first if you want. I have that fresh, right?
Yeah, no, good point. Yeah, why don't you start? I'll build off of you.
Okay. So with my coaching experience, I've always said like build a project as soon as possible, right? But you cannot do it in Rust or in any language because you need to know the basics. So I definitely recommend the Rust book, the official one that's free online, very well explained, and that gives you a complete tour to the language. But then, yeah, when I did that month of Rust, I did two things, right? I built small projects, and I just took Python scripts or things I'd built and just translated into Rust, because then you know it's something dear to you and you know what you're doing. So it kind of was a bit of a random journey, well, not random, but more like you're just faced with the reality and having to look up things from the get-go. And then I also actively taught it right from the start, because then when you have to teach it, you force yourself to really understand it. So that really worked for me. So build things, teach it, and fight the bar checker from the get-go. Like the compiler doesn't give you a chance. Like it's straight into the compiler, and that's also I think where you can really ramp up your learning journey, because by working with the compiler day in, day out, it will start to click. So that's just a nice feature of you have I think all three you have more like compiled language experience, so that doesn't sound like novel to you. That's for me as a scripter that was, right? So yeah.
No, it still is, even if you're coming from another one. It's still it's still a different. There's still a difference, but I will add to that. Second that, building a project right away, and actually putting down AI for a bit, at least measured in weeks. You got to put it down 100%. Like you can use it as an efficient research tool, of course, but don't do any coding with it. And I would even say, like, in your first weeks, turn off the autocomplete, like the old IntelliSense kind of stuff in your IDE, right? Just get it into your brain, the structure. And I think it still is worth it, even working with if ultimately you want to use Rust and you're going to use it with AI coding agents. Learn it for yourself first. Make sure you get it really, really well, not just to some level, shallow level, and you'll turn it over and you'll plateau then. If you want good Rust, learn it. It'll also teach you, not the highest level like software engineering patterns, but a lot of good, let's say computer science fundamentals, structures that will make better software consistently, no matter who's writing it. So start there. Shameless plug, our cohort is a really good place to start in 6 weeks. Pretty much everybody who's gone through it really didn't know Rust ahead of time, and they came out with, on a scale of 0 to 10, they've typically said 7, at least, their confidence on working with Rust for a future product. And so it's pretty effective, right? It's not going to get you into the advanced Rust right away, but it is going to get you, we'll call it 75-80% of the foundation of Rust that you can use. So that's a good place. But yeah, exercise it, make something real. I would say read a little bit about the theory to start with in the official Rust book online. You know, the equivalents of what you need to know from other languages, what you know today, and then start applying it, and then keep referencing back, right? Do this iterative learning model that we're quickly forgetting about as we outsource more to AI.
Yeah, that's a great point. Like that with AI, it's so easy to have this issue, right? But when you learn a new language, you have to really keep the friction. So that means going a little bit without it and really type out the code, which now sounds like the old way, but it's you have to do that, right? And,
Yep.
but yeah, I like also the CS side effect. Like many people in the cohort are saying, like, "Wow, it's like being in a CS degree again. Like I'm learning about computers," and so that's really cool. Yeah.
Yeah, that's it's interesting as you guys have been talking to it. I think it is something that maybe a lot of us are going to have to just keep on a sort of as our little back burner side project as we're going forward, is just learning some new languages from time to time, because it's real easy to get into the AI. And it's funny that you mentioned even the autocomplete, that you can get stuff that can really, speed wise, it can make a huge difference. But learning the actual libraries and how the language works and things like that, you got to get back to basics in order to learn it. It's not gonna. It can show you the syntax. AI can show you syntax all day. Autocomplete can get you to that that function or that class very quickly. But doing it yourself, I think it's one of those. It's going to stick more. It's a lot harder when it shows you how to do it than it is when you have to go figure it out yourself.
Exactly. I think the analogy is to like a human language. So if you thought about learning Spanish for the first time or something like that, and you were working with AI to do it the whole time along the way, it's pretty obvious you wouldn't learn it to a conversational level.
Mm-hmm.
You wouldn't be able to say, this is good Spanish, this is not good Spanish. So you need to learn it yourself to a certain level. And then, obviously this is where the analogy breaks down, because, maybe some people are asking Claude to speak their Spanish for them. But if you want to be able to use it yourself and improve the way you think and the clarity of thought, you got to do it yourself, at least for a period of time. I would say if you're very serious about learning it, I'd say a minimum of a year.
What, a year without AI? No way.
at least on Rust. Yeah, I know it sounds so prehistoric now. It's strange.
Yeah.
I love the idea though, because I've got a whole bunch of Raspberry Pis kicking around back to the version 2. I've got the W's, and my wife bought me a kit one year with all the wires and that to build the car. I think I'm going to have to go back to dig one of those out and start playing with Rust with that. It sounds like it would be a fun little project.
It's good fun. Rust is perfect for that. And there's a really good hardware abstraction layer for all the Raspberry Pi embedded computers in Rust. So yeah, that's what I've done the most on, actually. So you'll have good fun.
Oh, cool. Appreciate the idea.
Mm-hmm.
New hobby.
Yeah. Reach out if I can help you.
Oh, excellent.
Sure, I might, because you've given me some ideas. I might pick your brain on some places to start with the Pi.
Absolutely.
Nice.
Definitely. Well, thanks so much, guys. I want to be respectful of your time. This is awesome. Thanks for coming in. This was, I feel like this was incredibly successful for our first time to have more than one guest at a time. You guys teamed up well. I think everybody listening probably is going to be very curious about Rust now. If they haven't looked at it before, I think they're going to look into it. And I will say I think it speaks volumes that your cohort has that level of comfort with the language. There's a lot of we've spoken bad about some boot camps in the past that people come out of it and they're like, yeah, I can do the whatever the examples were they gave me, but I don't know if I can really use it in the real world. And to be that to that level of comfort, I think speaks a lot. So definitely, I recommend that to any of the listeners that are out there as well to check it out. It's a great way to, and never hurts to, I don't know how much it helps to have another language these days because AI can do so much with it, but I don't think it hurts either, particularly when it's a language that forces you to think a little bit differently about how you're building your software and your applications.
Yeah, for me, coming from Python, that's been a great help.
I will make a plug, though, for the general safety of software in the world, too, for Rust. It is, by default, much more secure and safe. Like, again, not a silver bullet. So like if you learn it for no other reason than that, to help, help the world have more secure software, then thank you. Please do.
I love that. I think that's a perfect way for us to wrap this one up. So those of you listening or watching, I guess now, because we're back to that part, thanks so much for hanging out. We appreciate your time, and you guys hang out with us. We will have links in the show notes for all of this so that you guys can reach out and learn more about Rust and maybe sign up for a cohort and be one of that. We will challenge you to do better than feeling 70%. We want you guys to be like, we challenge you to be better. Go in there, learn Rust, be up at that like 90% level or better, and share with us your Rust applications. That would be awesome to hear. So as always, have yourself a great one, and we'll talk to you guys next time. And Bob and Jim, thanks so much. We'll get this will go out in a couple of weeks. We'll get you guys links. Feel free to share it wherever you want. We'll hit you up in all the different places we can, and wherever we can help you out with directing people your way or anything else. We're happy to do so, because this has been great, and happy to allow you to evangelize, and happy to be evangelized too, I guess is how it goes. And it's been great meeting you guys for real as well, not just through LinkedIn and such.
Likewise, thank you. I
Yes.
appreciate your patience as we were getting scheduled too.
Not a problem. We deal with this on a regular basis now, since we're so many hour time zones apart. It makes it a little bit challenging, but thanks for being patient with that.
Of course. Yeah. No, this has been great. I really enjoyed this.
Yeah, I really enjoyed it as well. Thanks.
And nice meeting you guys.
You too. Yeah, and
same.
do reach out if you pull out a Raspberry Pi with Rust.
Yeah, I just bought 6 of them to do a training class, so now I've got to figure out what to do with them now that I'm done with the training class. So.
There we go. I'll have all kinds of recommendations for you, including some helpful hardware.
Nice. Appreciate it.
Awesome. All right. Thanks a lot, guys. Have a good one. We'll talk to you again soon.
All right. Thanks, guys.
Good to meet you guys.
Take care.
Have a good day. Bye.